Hello, what's up? Sliv. Excuse me there. Okay. So, just a quick little video. So, I was taught C, um, the C programming language when I was 16. This is about 12 years ago now. Well, it'll be 12 years ago this year. And mostly they had us work with Turbo C, doing 16-bit kind of work. Quite simple. We didn't really go into much detail, and then we quickly moved on to C++, and that was very much it. And so here's the interesting thing, right? Because I was taught to program with C++ and strictly, I mean strictly in an object-oriented manner. They barely gave me any time uh, to explore what was possible with programming before installing object-oriented ideas, ideology. I'm going to call it that in my brain. And so this is interesting because for many years, for many years, I thought that was all there was to it. Now, so that's sort of my background, right? But what happened, uh, a, I don't know, a couple years ago, something like that, is well, I sort of I very much realized that I didn't like object oriented. That's the short of it. I didn't like it because I realized that it's the principles themselves constantly force you to code yourself into a corner. And I guess I could give you some practical examples of this, but if you really want an in-depth explanation, you can just go watch Brian Will videos. He probably does a better job than I can. Now, even thinking that probably most of the critiques of object-oriented are valid, I'm still sort of like in good terms, in good terms with encapsulation, because if there's one thing that I realize is that uh, the kind of artificial limitations, because that's all it is, the kind of artificial limitations that you put upon yourself when you take on I will program in this specific way, right? Those kinds of limitations, what they do is they sort of make you go through some troubles in the short term in order to reap some benefits in the long term. And proper encapsulation, it's one of the times where this actually happens. Okay, so I'm going to give you like a very quick example. Okay, and this might not be the most well, I would say it's practical because it's code that I use, right? So it's code that I actually use. So, but it's not very a very long piece of code. So it just helped me get my point across without making this a too in-depth video. Okay, I'm still going to explain sort of what's going on. And so this is a clock, right? So it takes some delta every frame. It accumulates and Oh no, wait, sorry, it does not accumulate. It just takes the delta and sleeps. And that's that. Basics. But now the only thing you have access to is the method, right? So you can call this one method to get like a nice drawing of the clock, sort of rotating, which is this lovely thing over here. Where am I? Okay, you take a look at it here. You can just see it here, just floating around. See this little clock. Okay, so that's just an aesthetics thing. Oops. Then there's the tick, and this is just take the deltas and sleep if you have to, and a constructor. And there is no destructor. We just have a single static. Okay. Now, how is this encapsulated? Well, there are no setters and no getters. Okay. So we have a single program clock. So an executable utilizing this clock only has one, right? And the only way to modify this state is through this method. So in a sense, the state is still shared. So you could say this is not perfect encapsulation, and you'd be right. It is not perfect if we can modify this state, if external forces, so to speak, can modify this state. However, what we are doing is we are minimizing how much interloping can actually happen. And I mean, there's not really a lot you can do to manipulate this state. As a matter of fact, most of what you can do is just call the constructor in order to just make sure that everything is zero initialized, and passing in a new frame length and draw characters. Because yes, you can modify the clock at runtime. That's not something I do, but if you wanted to, you could. It does mean reinitializing there. And so this is a simple enough piece of code that serves some practical purpose and has reaps certain benefits from encapsulation. That's basically my whole point. So why is this useful? Why not just put everything on the header? Why not just do that? Well, but if we were to look at the object file for this, and actually an M, and that would be, oops, that would be trash can. Yeah, I call the object dump trash can. That's how you do things. So if we open up clock.o, you can see that everything, even this C symbol here, which supposedly is just it's hidden away, it's private, it's encapsulated, it's visible to the object file, because of course it needs to be. It needs to be visible. It needs to be loaded within the. Like someone is going, some theory guy is going to not like that I call programs memory mappings, but in my brain that's sort of what they are. it's a map of how you distribute memory and how you utilize memory. Okay, and so these symbols, you need to locate them within that map. In order to locate those symbols within that map, you need to know where they are and what they are, and that's why these things are visible. So the idea of certain symbols not being accessible is an artificial limitation. That's my point. It's an artificial limitation. Why impose such artificial limitations on ourselves? Well, because imagine that you had a larger file, something like the interpreter I wrote, where I did make this mistake of exposing everything. I'm going to show you that. So that would be in cur, source, and mammoth, appropriately named, and that would be in the boxes. I think I've shown this before. So this one is much more convoluted. It's much larger, and I don't want to get into the intricacies of how Bisou script works, but basically you have a lot of global state, of shared global state that affects a lot of pieces of a lot of moving pieces inside of the interpreter, and a lot of these you see you have here a lot of extends, and a lot of these don't even have their own namespace, right? Quote unquote namespace. They're not even inside of a structure, right? So we don't even have a way to know if RD TK is just some local that we've declared somewhere by accident, maybe, or or if it's part of some global object or whatever, right? We have no way of knowing, and that does lead to mistakes being made. Just inevitable that as you have more namespace pollution, that you will eventually come upon collisions. That's just inevitable. Uh, and so limiting what is visible to the developer, right? Not the program, not the compiler, not the assembler, most certainly, but to the developer, and what you have access to and what you do not. That sort of, on one hand, it helps. You can only mess around with these things, right? The other ones, you can't even touch them. You know, there's actually there's actually some use to that. There is actually some good use to that. And so when you declare a class in C++, usually what you do, and this is the way I was taught in school, you make all of the member variables, you make them all private. But now here's the mistake. People make you add getters and setters for all of those members. And in reality, what you want is to access those access as few of those members as humanly possible. Okay, so you want to minimize external modifying of the state. And well, if you need to get the state, that's a different thing, right? If you just need to get a state or get results, uh, that's something you can work. That's something you can work with more easily. But when you have one module over here and that module can just willy-nilly modify the state of another, that's sort of it leads to trouble. It does lead to trouble, and of course, there's always the risk that the more things that you expose, the more that one change to the implementation of which the dependent modules are not aware of, changes to that implementation will wreck the dependent modules, which is something you do not want. Ideally, what you do want is to have a sort of an interface, which is why we have these these header files, right? So why do we have header files? Because again, we want certain things to be visible to other pieces of code, but we do not want to expose every single internal because of all the things that I've been talking about. we do not want to expose everything because we would have shared state, and that with time becomes more and more unmanageable. And so that's basically why we have these things. And let me just take a quick look at this file over here. Now, here's sort of the thing. And let me gather my thoughts for a second. When you want to do a re-implementation, for whichever reason, suppose the initialization needs to be different. If when you were designing the code and, you know, too much planning sort of doesn't work, but you should prototype things out first, work with the code, and then once you start seeing the quirks and iron them out, then you start doing some designing. That's at least that's how I do it, and it works wonders for me. But anyhow, once you get to that proper design phase after you've done prototyping, you want to sort of define a clear interface that you know will not change, because that's the thing that's the thing that will inevitably mess you up. Okay, because the way you can do this efficiently is when you define this function signature, you will never change it. Okay, when you have to come to a point in which you say this function signature will not change anymore. We will not add more things to this one. We can add things to other ones, to other functions that perhaps do not yet exist, or other ones that are not exposed, but we cannot change the entry points, because that is what these things are, right? We call them, you may call it a header file, or you may call it an interface, or you might call it a class, or you may call it public members or first-class citizens, or some of that jargon. It's entries, okay? It's entries into blocks of code. It's entries into blocks of code, which sort of are moving pieces. Sort of are like moving pieces. You want to limit how many external forces can just influence those moving pieces. That's the way I think about it. It's a more basic-minded kind of way to think about it. But I feel like the more when you can think of it in more simpler terms is when you achieve actual abstraction in the software developing sense, right? Because the whole concept is that you want something that's utterly complex and fairly involved to be more 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 tied down, more nailed down to just uh, some core pieces which you can just, you know, push the button, so to speak. And this is the thing that I realized about a lot of object-oriented practices, in that in the end they will not have you simplify your code, they will have you make your code more difficult to read. More difficult to read, more difficult to work with, and it sort of detracts from the original purpose of encapsulation. Now, I mentioned Mr. Brian Will at the beginning, and I I'm pretty sure he's against encapsulation as a whole, so shame on him. Just kidding. He makes a couple of points, but in my view, object orientation as it is conceived of today is terrible, and you should not follow those principles. Absolutely not. But encapsulation itself, there is merit to encapsulation, but you need to do encapsulation um, not the way I do it necessarily. Not the way I do it, but because anyhow I do things weirdly, and uh, I'm painfully aware of that. But you need to find the simple way. You need to find minimalistic ways to work these kinds of things, because there is a trade-off. There is a definite trade-off. If I had all of these uh, all of this code, see here, and this is actually the way I originally developed this software. What I did initially is here where it says include clock.h, is I had the entirety of clock.c, and where it says display.h, I had the entirety of display.c, and so on and so forth. Those modules were originally just one big monolith, and all of that all of that global state that I have tucked away into a static struct, I originally had all of those chunks of data within this struct, okay? Uh, which is something I do just to be a little bit more orderly about it. So I want all of the global state for a given file as much as I can do inside a single structure, okay? So it's just to remind myself that if I'm accessing this element here, I'm messing with the global state, okay? It's just the way I do that. And let me tell you something. It was far easier. It was a far easier for me to work with the code in that state. And the reason why is that, well, I for instance, when I wanted to modify the state of the keyboard, I just had to write to an address that was visible to me from that source file. I did not have to invoke a function. And yes, the overhead of a function call to modern hardware very much negligible, I think would be the right word, right? So insignificant. And yes, this is true, but there is an overhead. There is an overhead. This is the point. There is an overhead. You multiply every time there's an overhead. You need to do the mental exercise of multiplying it by 1,000. Okay, multiply by 1,000, and if possible, a couple 100,000. Okay, that's something you should do. And so if there is an overhead to making a function call versus just writing to an address that you have access to, you really do need to ask yourself, is it worth it? Because there is a trade-off. That's what I'm trying to get at. There is a trade-off in encapsulating. It means you are trading performance, even if it's in a very minimal scale. You're still trading performance, and so you should not do things like that without a good reason. What was my reason for doing this? I wanted to reuse the keyboard code, right? Because this is something I don't want to define every time, and it's certainly something that I would like to not have to recompile every time. Okay, so I would like it if I could compile my keyboard code once for every machine at least, uh, once for every machine, and then just link against it, um, or call some binding from Perl or whatever. And because I wanted to do that, I knew that, well, I had to do some wrangling, right? So the trade-off was worth it because it was in my best interest to be able to reuse this code without being able to recompile it every time for every project, because that's one of those things that annoys me. It's fine if I have to recompile a file or an entire project, but just that project. But if I have to recompile the same file for every single project, then it becomes a problem. So yes, when you want to reuse code, then there is more of a purpose to encapsulation. But when it's something that's more local to your application and you're using it nowhere else, why would you? Why why would you just so your code is object oriented? That doesn't make any sense. Um, because in the end, like I said, nothing is really private, right? Nothing is really private. It's an address in memory. It's an address in memory. That's all it is. Um, so yeah, I don't know. I feel really distanced to a lot of the of this software world at large, because I hear all of these things, all of these very complicated terminology and methodologies and all of the buzzwords and technobabble that amounts to nothing. Um, because I mean, if there was some more definite merit to all of this, then I'm pretty sure most programs I use wouldn't crash quite as much as they do. Okay, so that's sort of my takeaway here, right? A lot of programs I use crash a lot, and those that don't crash use way too much memory. I think way more than they should, uh, or they're painfully slow, right? Things like that, and and someone that's kind of naive and first worldish would say, well, just get more memory or upgrade your rig. Well, with what money? Okay, with what money? I don't have any money. I'm broke. So you have little resources to spare, and so every performance trade-off matters to me. And this is something that blows my mind, that it seems to me like I'm the only idiot that cares for these kinds of things. That I hear every now and then that software engineering is all about minimalism, but I don't see people trying to be too minimal about what they do. And I mean, I guess I'm guilty of that to an extent, because sometimes I do write code that's a little bit more complex than it should be, probably. but I make an effort not to fall into that. Okay, so I actually do want to be as minimal as I can, to keep code size as small as I can, to keep the memory footprint as small as I can. I don't know. At least, I mean, I may not find all the success in the world, but at least I'm trying. I'm trying something. I'm not just perpetrating the problem. I'm trying to find a solution. I don't know. This became a little bit of a rant. I don't remember what my point was quite exactly. But anyhow, just your daily reminder to subscribe to Space Wave Cosmic Relaxation, which is one of my favorite channels, by the way. So do subscribe to them. So anyhow, yeah, that's it from me. Have a good one.